So today I'd like to make sure that you can apply what we just learned about sine curves to generating an equation from what we did. Okay, so you'll notice this was our equation, A sine BT plus C plus D. How do you figure out what the A, B, C, and D are? So here's how you want to attack it. Start with the D. Find the midpoint of your sine curve, the average. So your most extreme value on either side, average them out. That'll give you the middle of the graph. You circle that value, and that value will tell you how far you are from the x-axis. That is the number that goes in for D. So find D first. Once you've established that, find out how far away you get from that average. What is the farthest you get above it? What is the farthest you get below it? That will give you your amplitude. So in this case, it's 15. We go from 20 to 35, which gives us an amplitude of 15. Next, you look at where you started. In this case, we started at our most extreme value. That corresponds to a phase shift of pi over 2. So we got D, we got A, now we got C. Once you have C, you could then count your cycles. So you can count off how many cycles there are. Again, don't start at the beginning. Start when you're done the first full cycle. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cycles in 4 seconds. That'll get you your frequency. You divide. And remember, the B value is frequency times 2 pi. So now we have D, we have C, we have B, and we have A. We now have all the variables, and we can write out the equation of this sine curve. The final answer would look something like that. This sine curve would reproduce if we use that equation. Amplitude, frequency, phase shift, vertical shift. Okay, how does it relate to our pendulum? Okay, so if you take a look at our pocket lab, how could we get a sine curve based on the parameters of our lab? So if you look, the first thing we always do is get the D value. We know that it's the average for our sine curve, but how does it relate to our pendulum? Well, it turns out that the D value would be the distance to the ball when the ball is hanging straight down. That would be the average position of the ball. Next, we would find A, the amplitude. The amplitude is determined by how far back we pull the ball before we release it. Okay, so that is the A value. The next value is the C value, and that is the starting point of our graph, and that is determined by when we hit collect. If we want to have it start at its most extreme value, we want to hit collect when the ball is as far as possible from the pocket lab. If we wanted it to start down here, we should hit collect when the ball is as close as possible to the pocket lab. So C is controlled by when we start collecting data. Finally, the B value is out of our control. We control the A, the C, and the D, but we do not control the B. The B is controlled by nature. We learned that the period of the pendulum was given by this formula. So we also learned that we could then find the frequency, and we learned that the B value is frequency times 2 pi. So this B value is determined by the length of the pendulum. Okay, it is not controlled by us so much as it's controlled by nature. Depending on the L value, nature will produce a certain B value for this sine curve. Okay, so one last time. D is your vertical shift. A, amplitude. C, phase shift. B is based on the period or the frequency. Vertical shift, amplitude, phase shift, determined by period and frequency. Remember, once you got your frequency, to find the B value, you just multiply it by 2 pi. Alternatively, you could take 2 pi and divide by the period, and that will also get you your B value.